Now, my good friends, we are talking about, today we want to talk about application of differentiation in two ways. Number one, in kinematics, and in two, in finding the area, in finding the gradient function, the gradient function, the gradient, the curve, and the turning point, and the nature of the turning point of the curve. Now, the first thing we want to talk about is now the kinematics. You know that the kinematics is the motion of bodies. Now, here we have a body. For example, we want to talk about a body moving in a straight path. Now, they are saying that the distance covered by a body by a moving particle through point O, a fixed point O, is given by the equation S is equal to t cubed minus 15 squared t squared plus 63t minus 10. Find the distance covered when t is equal to 2. Now, the distance, when you know that S is always given the distance. S is always the distance. S is given the distance or called the displacement. Then V is always given the velocity or called the speed, and the other words the speed. Then A is also the acceleration. Now, you look at that equation there. They said that S is equal to t cubed minus 15t squared plus 63 minus 10. Then that is S. Now they are asking us to find the value of the distance, the value of S, the distance, the value of S when t is equal to 2. Now, what do we say? You find that the S, this is S equation, which is the distance equation. This is the distance equation, displacement equation. Now, they want that distance when t is equal to 2. Now, what we do, we take that the same equation, S is equal to t cubed minus 15t squared plus 63t minus 10. Now, and this one here, when t is equal to 2, we replace the value of t at this point with 2, because t is equal to 2 to get S. Now, S is equal to 2 cubed, minus 15 into 2, this one squared, plus 63 into 2 minus 10. Now, 2 cubed is 8. Then that is 60. Minus 60. That is 60. Because 15 times this is square, this one, that is 4. Now 15 times 4, that is 60. Plus 63 by 2, that is 126 minus 10. Now finding that now it is 8 minus 60, 8 minus 60 plus 126 minus 10. You find that distance is 64, correct? That distance is 64. Now the value of S when t is equal to 2 is 64. Then the distance covered during the third second. To find the distance covered during the third second, you find the distance during second when t is equal to 2 and when t is equal to 3. Now when t is equal to, you subtract. Now t is equal to 3 minus t is equal to 2. You find that t is equal to 3 minus t is equal to 2. Now we find it, but when t is equal to 2, we found to be 64. When t is equal to 2, we found it to be 64 meters. 64 meters. Now we are finding when t is equal to 3. What do? We again substitute the value of t, which is equal to 3, into the original equation, which is, when we substitute it, it will be 3, this one cubed, minus 15 into 3 squared plus 63 into 3 minus 10. 3 that t is 3 now. T there is 3. Now t cubed, that is 3 cubed, minus 15t squared, that is 15 times 3 squared, minus 63 t, that is 63 times 3, then minus what? 10 plus, plus 63, then that is minus 10. If you look at this, I think this is 27 minus 15 by 9, minus 15 by 9, minus 15 by 9, minus 15 by 9, 15 by 9, minus 15 by 9, find that minus 135, plus 63 by 3, plus 63 by 3, plus 63 by 3, plus 63 by 3, that is 189, plus 189, plus 189 minus 10. Now at that point we find that the value of the s when is equal to 3, s is equal to 3 is equal to 27 minus 135 plus 189 minus 10. Now it is 27 minus 135 plus 189 minus 10. We find that one is 51. Find that one is 51. Seriously. Seriously. No. Now, okay. When t is equal to 3, we substitute t into the equation when t is equal to 3. That 3 cubed, that is 3 cubed. S is equal to 3 cubed, that is 27. 3 cubed is 27, I think so. 3 cubed is 27. Is 27. 3 cubed is 27 minus 15. 15 by 4, which is 60. Minus 60 here. 15 by, it is 15 by 9. 15 by 9. 15 by 9. 15 minus 15 by 9. By 9. 9, that one. 15 by 9 is 135. Plus 63 by 3. Plus 63 by 3. Plus 63 by 3. By 3. That is 189. Minus 10. Now that's minus 10. Now I can say 27 minus 135. Minus 135 plus 189. 189 minus 10 is equal to 71. Now find that one is equal to 71 meters. Now this is when t is equal to 3. But when to find when t is equal to, when at the third second we take when t is equal to 3 minus when t is equal to 2. Now we find that when t is equal to 3, 71. Now we find that 71 minus 64. We find that the distance covered in the third second. 71 minus 64. 71 minus 64 should be something. 71 minus 64 should be 7. 71 minus 64. 71 minus 64. 71 minus 64 should give me 7. Now we find that when t is equal to, in the third second, it covered 7 meters. Now, the next one, time when the particle is momentarily at rest. The time when particle is momentarily at rest means the velocity is equal to 0. When the velocity equation is equal to 0. And when to find if you look here, we have S equation. That means the velocity equation we doesn't have. We have to come out with the velocity equation. And when you have S equation, go to velocity equation, differentiate. Then you go to acceleration equation, you differentiate. Now to get the velocity equation, it's a differentiation of what? Of the S equation. Now velocity equation, there's differentiation of S equation, and you know the rule of differentiation that when that is x, when raised to power n, we take n pre-multiply by the coefficients of x. Now at that point you will find it is n multiplied by the coefficients of x, then raised to power n minus what? 1. That means the power reduces by 1, then the power, the original power pre-multiplies the x, then the power, it's the original power reduces by what? By 1. Now we find that to do that, we want to differentiate this equation. We find out to differentiate it, we find it is velocity equation v is equal to 3t squared minus 30t plus 63. If you look at that, how does that one come? 3t squared, 3t squared. Power pre-multiplies this one. We find that this is 3, then power minus what? 1. That means that's why we are come with 3t squared. Then this one here, this one pre-multiplies that. this pre-multiplies this, that is 30, then this minus 1, that is 30 times 30t raised minus 30t raised to power 30t raised to power 1, and when t is raised to power 1 it remains to be what? To be t. Then that means it is 30t. Then this one here is this, it is raised to power 1, then multiply by it remains 63. Then this one now is raised to power 0, then 0, then when anything raised to power 0 is equal to 1. Now that means t is equal to 1. Now 63 times 1, it remains 63. Now that is my v equation. Now that my velocity equation, it becomes is equal to 0 because it is momentarily at rest. That means the velocity v is equal to 0. Velocity v is equal to 0. Now if you look at this thing, it is a quadratic equation which can be furtherly simplified. Like 3 is constant, I can divide by 3 both sides. I find that the velocity t squared minus 10t plus 21 is equal to 0. Now I find the value of t at that point. T squared, I find the value of t at that point. I find the value of t at that point. I use the quadratic formula, that is minus b plus or minus the root over b squared minus 4ac over 2a. Now if I deal with that, I find that minus b, look at the values here. A is always the coefficients of t of x squared, which is a is equal to coefficients of t what? T squared. That is 1. A is equal to 1. Then b is the coefficients of b is the coefficients of what? T. What is that? Negative 10. B is equal to negative 10. Then c is the constant. C is the constant, which is c is equal to 21. Now place them here. We find negative b. Negative b is negative 10. Now I find that is just 10. Negative times a negative, that is just 10, plus or minus the root over b squared. B squared is 100 because negative 10 times negative 10 is 100, minus 4 times a, 4 times a, which is 1, times c, which is 21. 4 times a times c, which is 21, over 2 a, and a is 1. Now that one is over 2. Now when you multiply this thing here should give me 84. This one is 84. That one is 84. This part here is 84. This one in bracket is 84. Now 100 minus 84 is 16. Now I can say 10 plus or minus root of 16 over 2. But root of 16 is 4. Now root of 16 is 4. Now I'll say 10 plus or minus 4 over 2, which is equal to 10 plus 4 is 14, over 2 is 7. Then 10 minus 4 is 6, over 2 is 3. Now I find that when the particle is momentarily at rest, when the value of t, the time when the particle is momentarily at rest, is when it is t at 7 seconds, when it is at 7 seconds, and when it is at 3 seconds. You found how I've done it. I can show you. I've said that when the particle is momentarily at rest, is the v equation is equal to 0. Velocity is equal to 0. When a particle is at rest, that means that it's not moving. Velocity is 0. A 0 velocity. Now, velocity from this point we are given only the s, the displacement equation. Now, this displacement equation, to get the velocity equation, we differentiate the displacement equation. And on differentiating the displacement equation, getting the velocity equation, I'll get 3t squared minus 30t plus 63 minus 63, which is equal to 0. Then, being that 3 is common in this equation, I can simplify the equation further, and I divide by 3 throughout. I find it is now t squared minus 10t plus 21 is equal to 0. Then if you look at that, it is a quadratic equation, because quadratic equation is always in the form of ax squared plus bx plus c is equal to 0. Now, and if you look, this one here confides to that equation. If you look at this one here, confides to this rule. This rule here confides to this equation that we are given here, meaning we have a quadratic equation at that point. Having a quadratic equation at that point, we solve for the value of t from that quadratic equation, and by use the quadratic formula, this is the quadratic formula, solving for the value of t. Now the value of t at that point, you find that now these are the coefficients a, b, and c. Now after that one there, you substitute them into your quadratic formula, then you get your the first value of t to be 7 seconds or 3 seconds. This is 7 seconds or 3 seconds. This is when the particle at rest. That means when the particle at 3 seconds, it will be at rest. Then it moves again at 7th second, it is also at rest. Then the next thing we want to do is the acceleration when t is equal to 5. Now the acceleration, just like I said, that you start with the distance, then velocity, then acceleration. If you go that way, as you go that way, you do what? You differentiate. Now the next thing, I differentiate to get the acceleration. I differentiate the velocity equation. I differentiate the velocity equation at this point is equal to differentiation of the velocity equation to get the acceleration. Now the acceleration equation is equal to differentiation of the velocity equation, and the velocity equation is this. You see, the velocity equation is this. Now its differentiation of the velocity equation will be 6t, look, it is 6t, this 2 times 3, that is 6t, you look, it is 6t here, 6t, then minus 30, because minus 30, you find it's minus 30. If you differentiate this 30 here, this equation here, it will be 1. This is 1 times 30 is 30. Then this one is 1 minus 0, which is 0. 1 minus 1, which is 0. Then this, now anything raised to power 0 is always 1. Now 30 times 1 is 30. Now we say it is 60 minus 30. Now that's 60 minus 30. 60 minus 30, this acceleration. Then we want that acceleration. They want that acceleration when t is equal to 5. What do? Acceleration is equal to, I replace this value of t with what? With 5. I replace this value of t with 5. I replace this value of t with 5. I'll find that the acceleration is equal to 30 minus 30. The acceleration is 0. That means the body, when the acceleration is 0, that does not mean the body is constant, but the body is at constant acceleration. I mean, not constant acceleration, but the body is at constant acceleration. When the acceleration was when acceleration is 0, it means the body is moving at a constant velocity. There is no change in velocity. Then acceleration is 0. When the acceleration is a negative, it means the body is now coming, the body is retarding. The body is changing the velocity from higher to lower. Then when the acceleration is positive, the body is increasing the velocity. Now we find that is it when we are dealing with the acceleration, and that is